Hey everyone, and welcome to This Explainer. Today we are looking at something absolutely fascinating. If you've ever wondered what it looks like to build a highly secure, incredibly complex financial machine totally from scratch, well, you're in the right place. We're unpacking the recent summer development sprint by Flux Studios. And let me tell you, over the course of just a few weeks, they executed this massive, rapid assembly of the Aegis protocol. We're not just talking about a standard software patch here. This is the literal construction of a next-generation, decentralized insurance platform, put together piece by critical piece. Okay, let's dive into this. Flux Studios are the architects driving this huge push. Now, they usually have their hands full with a bunch of different projects across their tech stack, things like the Atomo desktop app and the Materios gateway infrastructure. But their dev digests from this summer reveal an intense, laser-focused dedication to one specific product, Aegis. We are going to look at exactly how they turned high-level concepts into shipped code at absolute breakneck speed. To really understand this technical progression, here is our roadmap of how the protocol was built up layer by layer. First, we'll look at the blueprint, then the vault, the nervous system, the engine, and finally, the paint job. But before we get into the nuts and bolts, let's just briefly clarify what Aegis actually is so we're all on the same page. Aegis is a parametric insurance protocol. If you're not totally deep into the developer jargon, parametric insurance basically means it relies on smart contracts to automatically trigger payouts based on objective, totally verifiable data events. Think along the lines of a stablecoin losing its peg to the dollar. There's no claims adjuster sitting in an office manually reviewing your file. It's binary, it's instant, and it's entirely code-driven. All right, Section 1, the blueprint, a summer of shipping. When you look at the developer logs, the word that instantly comes to mind is velocity. They weren't just in there swatting bugs, they were shipping foundational architecture at a staggering pace. Just to give you a sense of scale here, 10. That is the number of commits specifically for the Aegis protocol in just a single day's dev activity. That made up the bulk of the studio's work that day, totally outpacing updates to things like the Matra token merger or the Saturn swap filler. This represents just this intense, unified focus by the dev team to push Aegis toward mainnet readiness. Moving on to Section 2, the vault, treasury cover, and multi-sig. Now, what's really interesting about this slide is how these specific SDK updates enable incredibly advanced features like underwriter vaults to exist securely on-chain. When you're building a decentralized insurance protocol, security isn't just a fun add-on feature. It literally is the entire product. If the treasury isn't secure, nothing else matters. So merging pull requests for liquidity composers, policy encoding, and direct delivery to script addresses, yeah, I know it sounds like deep dev jargon, but trust me, they are the structural steel of this whole operation. And that brings us to this massive milestone. Treasury cover went from a mere concept to being practically shipped. They provided a full end-to-end proof for 2 of 3 multi-signature treasury payouts. To put that simply, to move funds, you need multiple cryptographic approvals. It completely eliminates a single point of failure. It proves the vault can actively and securely manage real payouts without relying on just one centralized key holder. But, a vault is really only as good as its resistance to attacks, right? The logs show they rigorously tested this architecture. They applied specific red team security fixes, like the RT01 ADA-only commitment requirement. They corrected mainnet slot offsets, and they actively hardened their deployment ceremonies. Basically, they were intentionally trying to break their own system. They did this to ensure that when real user funds are at stake, that vault remains locked tight against any kind of exploit. Which brings us to Section 3, the nervous system, oracles and fail-safes. If the treasury is the vault, the oracles are absolutely the nervous system. Remember, parametric insurance relies entirely on objective data. If a stablecoin depegs, the protocol needs to know immediately and accurately to trigger a payout. So Aegis brought their depeg oracle feed live on mainnet. But what is absolutely crucial here is the built-in resilience. Their primary data comes from a DEX-derived price source, but let's be real, decentralized finance can be a wild ride, so they implemented a backup, the Pyth Hermes failover. If the primary feed glitches or throws anomalous data, the system instantly catches itself. It's a brilliant safety net. Alongside that failover, they brought Oracle-keyed underwrite gates and USDM depeg rebinding live. What that means is the protocol can securely reconnect to accurate pricing if a peg actually breaks. These aren't just passive data feeds, they are active defense mechanisms. These failsafes protect the protocol from bad data, ensuring that underwrites are gated properly, and it only ever responds to verified, accurate market realities.
All right, Section 4, the engine, Genesis pools and staking.
Let's move to and see how this builds. With the vault secured and the nervous system wired, the developers shifted their focus to the active mechanics of Aegis. This is the engine that actually drives the protocol's economy, and you can see their dev efficiency when you map out this timeline. In mere days, they staged the pre-production staking ceremony. Within weeks, they successfully wired mainnet hashes, and in just a matter of months, this rapid deployment culminated in landing the Genesis Commitments pilot. Going from staging a mock environment to landing a live, demand-gated funding mechanism that fast, that's a huge testament to their focus.
I actually want to highlight this specific quote directly from the Dev Digest. Genesis Commitments MVP shipped, demand-gated pool building for the protocol. Notice the momentum words in there, shipped and demand-gated. We aren't just talking about theoretical white paper concepts anymore, folks. The protocol's engine for building capital pools based on actual user demand is real, and it is ready for the real world.
Finally, let's slow the pace down a bit for Section 5, the paint job, polishing the user experience. All of this incredible backend architecture, the multi-sig vaults, the failover oracles, the Genesis pools, it's kind of useless if people can't figure out how to actually use it. To make this dense technical capability accessible, the team totally reorganized the UI. They promoted the staking panel directly to the top bar for super easy access. They moved the auto-claim wallet out of the way into the settings menu just to declutter the screen. And they spent time really polishing the commit panel user experience. All of this softens the learning curve, making complex decentralized insurance feel smooth and intuitive for the everyday end user. And this brilliantly illustrates the ultimate goal of the summer sprint. Flux Studios didn't just build a highly secure backend. They built a bridge. They successfully connected hardcore, red team-tested treasury mechanics with seamless front-end usability. They essentially painted this incredibly complex machine in a way that users can actually interact with safely and easily. So, we've seen the whole shebang: the blueprint, the vaults, the nervous system, the engine, and the paint job. Aegis has evolved from a concept to a shipped, demand-gated protocol in a matter of weeks, which leaves us with one massive question. With the vault secured, the oracles running, and the UX polished, what will the full mainnet impact of Aegis mean for the future of on-chain parametric insurance? As these safety nets go live, the entire decentralized finance landscape might just be about to change. Thanks so much for joining me on this explainer, and keep learning.